In this video, we're going to find or compute some parameters, particularly the mean, variance, standard deviation, and skewness for a finite distribution. So see if you can use the formulas that we developed in our last couple of videos to work with this here. So I'm going to be asking you to work these out and check your work as we go along. So here is given a, well, almost complete PDF table. So first of all, finish the PDF table and make a CDF table for this. Okay, go ahead and press pause now. Okay, now that you're back, you can see that that sum has to be 1, so hopefully you figured out that the last value there had to be 0.6. And then the cumulative the CDF, now we can fill that out as well, and hopefully you've done that. Notice it always ends at 1, and hopefully you have that. Next, let's find the mean. Press pause now. Okay, now hopefully you've actually worked out the mean. First, define the mean from a PDF table like this. We don't need the CDF column, but we take the x times the PDF and put them here. So 2 times 0.1 is 0.2, 5 times 0.05 is 0.25, and so forth. And then we add those up to get 8.95 in this case, and that is the mean. So the mean is 8.95. Now, let's see if we can find the variance. Now, you may want a calculator or a spreadsheet to help you with these calculations here. But I have some of the interesting parts here that you want to fill out for the table. Press pause. So we do the x minus the mu's. So mu is always 8.95 in this case for this problem. And we take the x value minus that. So 2 minus 8.95 is negative 6.95. Okay. 5 minus 8.95 is negative 3.95. 7 minus 8.95, negative 1.95. 8 minus 8.95 is negative 0.95. 11 minus 8.95 is 2.05. Got some extra zeros here I don't really need. Now if I multiply those by the probabilities and then add those up, those always turn out to be 0. This is something we do not need to do, so we could skip this column altogether actually. Now let's go ahead and fill out these the last two columns here to figure out the variance and standard deviation. When you get done with that, come back and check your work. Alright, so now that you're back, what we're going to do is we're going to take these x minus mu values in this column and square them. So just use your calculator. Negative 6.95 squared is 48.3. And negative 3.94 squared is 15.6. Negative 1.95 squared is 3.8. 0.95 positive or negative squared is 0.9. And 2.05 squared is 4.20. Then take each one of these, multiply by the probability. 0.1 times 48.3 is 4.83, and so forth. I think some of these are rounded off on the squares, and these are probably rounded off too, but to more digits. Now add up all of these here, and there's the variance. Take the square root of that, and there's the standard deviation. Some of these are probably rounded a bit, but there's the answer. So now we have the variance and standard deviation. So we have a measure of center, 8.95, the mean. We have two different measures of spread, the variance of 8.6475, and standard deviation of 2.9407. And then we can compute the skewness as well. Okay, so here's how the skewness works. We need to find z-scores for all of these guys. So now that we have a mean and a standard deviation, we can do x minus the mean, so that's this column right here, the negative 6.95. Take that and divide by the standard deviation. So we're basically taking everything in this x minus mu column divided by the standard deviation of 2.940663, and we get these values here, which are z-scores. So only one of the numbers was above the mean, the 11. So that's our positive z-score. The rest are negative. Now we're going to cube these. These will still be negative. Negatives will stay negative. Positives will stay positive. Numbers will change as we cube those to get these numbers here. And then multiply those by the probabilities. So see, where's the probability? That's the second column here. 0.1 times negative 13 point something is negative 1 point something there, and so forth. 0.05 times negative 2.423569 is negative 0.121178, etc. And so I did all of those, add the numbers in this last column, and that's a skewness. So with the negative skewness, we know it's skewed to the left, at least a little bit. The closer that skewness is to 0, the closer it is to being symmetric. So the final thing I'd like to ask you to do is to go ahead and make a PDF graph of this. And there it is. We can also see the mode very easily there. We could also talk about the median. So if we look at the CDF file, the first one that goes 0.5 or bigger, that's the median, which in this case the 11 is not only the maximum, it's the median as well. Okay. So I want you to take a little time to look over these numbers and make sure you can get them with your calculator. Make sure you know where they're all coming from. So when you're satisfied you understand this slide completely, then go on to the next one. But pause it and think about it a little bit first. Press pause now. Well, the good news is our calculator can do a lot of this stuff for us. Here's how you can do it on your calculator. Here's a TI-84 version. We're going to enter in our PDF table. So you're going to hit Stat and Edit. Here's our PDF table that we essentially started with. Stat and Edit. Put your cursor on the L1, hit Clear and Enter. Then put your cursor on L2, hit Clear and Enter. So make sure you have blank lists for L1 and L2. In L1, type in the X values 2, 5, 7, 8, and 11 by typing, put your cursor right here where the 2 is. Type 2, enter, 5, enter, 7, enter, 8, enter, 11, enter. Right arrow, and it'll put it where this 0.1 is, enter the probabilities in list 2. 0.1, enter, 0.05, enter, 0.1, enter, 0.15, enter, and 0.6, enter. And now you have the X's in L1, the probabilities of the X's are the values of the PDF in L2. If you want to find the CDF, there's a real easy way to do that once you have the probabilities here. Now these need to be in increasing order for this, which they are, so make sure you do that first. Then put your cursor on the heading for L3. Actually, you probably want to go ahead and then hit Clear and Enter to clear that out. So now we got a clear column for L3. And just type in cumulative sum of L2 and hit Enter. Now cumulative sum is, it's written right here, list ops 6, cumulative sum. Okay, and then L2, which is second 2, close parentheses, enter, and it will, notice it will give you a cumulative sum of L2, which is in fact the CDF. So you have the values of the PDF in L2, the values for the CDF in L3. Now we can figure many of the, just like we can do many descriptive statistics, we can do the parameters here in this case with one variable statistics. So quit, second mode, get back to the home screen, hit, let's see, Stat, and then go to right arrow to calculate, and then choose number 1, one variable statistics. List is L1, its frequency is L2, and hit calculate. If you've got the older operating systems, this screen right here will not come up. So in which case you would just type one variable stats, and then you put in L1, L2, and enter. And then either way it will give you this. Notice it's treating this, since these are given as relative frequencies or probabilities, then you're going to get X bar, which is not really X bar, it's now actually mu, because this is a population, is 8.95. We're going to get sigma, 2.94, which is what we got before. And arrow down, you can see the median and max are 11, the minimum is 2, and so forth. It gives you quartiles as well. If we want to take the sigma and square it, that gives us the variance, which we had computed earlier. Now, to get this, you can go to Variables, VARS key, and choose number, I think it's 5, which is statistics, and you'll find sigma of the x's here. Square it, and you get the variance. You can work a similar way on a TI Nspire. Make sure you add a spreadsheet page like this. Enter the x's here, and I just called it data, and then PDF here, and put our data in like this. Make sure that's the only thing there. And for column C, I could put my cursor in the cell right here below the C, right here, and type in cumulative sum of the PDF column. And you can get cumulative sum from menu. Hit the menu button, do 3 data and 7 list operations, and choose number 1, cumulative sum. So you can find those through the menus, and it will give you that. Now to compute the parameters, there's a CDF then is in column 3, and I labeled it CDF. Column C. And you can do the one variable statistics on this calculator by, well, let's see, it's menu, number 4, statistics, choose number 1, stat calculations, and then number 1 again, one variable statistics. So if you know these numbers, you could just type menu 411, will give this to you. But you can also just use your arrow keys to navigate the menus. So it's menu, statistics, stat calculations, one variable stats, and then you get this wizard here. My X list is in the list I called data. The frequency list is in the list called PDF. Of course, it's not really a frequency, it's a relative frequency, but that's how you entered it in the calculator. And the rest you can leave blank basically and hit OK. And it says first result is in column E. And so then starting with column E, let's see, it skipped over D, and it puts some labels in E and values in F. And so you can see there's X bar is 8.95. And then if I down arrow a little bit, you'll see sigma is 2.94. And I could go over here and just say square the one that's next to it, and I'd have the variance there. And down here somewhere are the median, for example. And if I go to my graph, I can, or go to my data plot, add a data graphical screen, and then you'll see these sort of random dots just looking around there. Click down here on the bottom and put data, and over here put PDF, and all of a sudden these dots will come in to the right, they'll actually see them move around the screen to the right places, and these are basically the tops of the bars for a bar graph. Okay, so see, you try this on your calculator. Here's another finite distribution. It's missing one cell, so you need to fill that out first. They're already in increasing order. So go ahead and compute the mean, variance, standard deviation, and skewness for this one. Okay. Press pause and come back when you got them figured out. Here they are, and there's the PDF graph. It's skewed to the right a little bit, we can see. Here's all the details worked out. Multiply x's times the probabilities and add those up. That's a mean of 2.5. Take the x values minus the means here. We multiply them by the probabilities and add up. That's 0, sort of a check. That column we really don't need. You could skip it. Do the x times the probability times x minus the mean. Sorry, take the x minus the mean, square it first here. Multiply that by the probability, which is here. Add those up, that's the variance, square root of that's the standard deviation. Find z-scores, we take the x minus the mean, which is this column right here. Divide by the standard deviation, which we just figured out, so dividing by 1.3287, etc. every time. And we get these values here. Cube them, that's cube of z values. Multiply those by the probabilities, we get this last one, and add those up, that's the skewness. So these sums, the only ones that are important are the, well, this should add up to 1, that's for sure. This mean is just sum here, or this column. Some of this column is the variance, and some of this last column is the skewness. Notice it is a positive value, so you see skew to the right. All right, here's another one. In this case, I'm giving you a formula for the PDF. And I'm saying x can be either 0, 1, 2, 3, 4, or 5. The formula for the PDF is 5 choose x times 0.4 to the x times 0.6 to the 5 minus x. So use that formula to come up with the values of the PDF, and then use the values of that to make the CDF part compute the mean, variance, standard deviation, and skewness. And again, if you want to use your calculator for a shortcut, use it when you can. That's fine. When you get this one worked out, come back, press pause now. Here it is, worked out. These PDF values, at least they're rounded off a bit, but they're computed using this formula. Notice that they do sum up to 1, and if you just do the cumulative sum, actually I asked for the CDF, but I didn't give it to you here. But what would it be? It would be 0.0, same as that one for the first one. It'd be these two added together for the next one, first 3 added together for the next one, and so forth. The other things I ask you to find out, you could do by taking the x's times the probabilities, which are here, and add those up, and that's the mean, which is 2 in this case. So you take the x's minus the mean. Those are nice integers. This one is not important, but we take these x's, x minus the means, and square them, which gives you these. Those are pretty easy to do in your head there. Take these values times the probabilities, so the 0.07776 times 4. And by the way, how did I get 0.07776? Well, let's just plug the 0 in here. It's 520 times 0.4 to the 0 times 0.6 to the 5 minus 0. And that's at least approximately that. Then over here, once I have these values here in this column, I just add those up, and that's my variance. Square root of that's my standard deviation. Once I have a standard deviation and a mean, if I want to find the skewness, I need to find z-scores. So I want to take the x value here minus the mean, which I already have that worked out here, and divide by the standard deviation. So I divide everything in this column, x minus mean column, divide every one of them by this standard deviation down here, and I get the things in this column, cube them, take these cubes and multiply by the probabilities in the second column to get the stuff in the last column, add those up, and that's the skewness. So this is very slightly skewed to the right, but pretty much really close to being symmetric here. Okay, let's do a couple of graphical interpretation problems for these parameters. Without computing a value for it, just looking at this, which one has the largest mean, smallest mean, and the one in the middle? And what about skewness? Press pause and come back when you think you have an answer. Well, problem B is symmetric with 0 skewness, so the mean will be right in the middle of 3. Problem C has the mean is skewed to the left, and the mean is going to be higher than 3. The mean will be less than, is skewed to the right on A, so the mean will be to the left of that, will be less than 3. So let's see, the lowest mean is A, middle mean is B, and the highest mean is C. The most amount of skewness is in C, but it's negative skewness, and you got positive skewness in A and 0 skewness in B. All right, what about these? About standard deviation. Which of these has the largest standard deviation, which is the smallest, and which one's in the middle? Press pause and come back when you think you have an answer. Well, the smallest variance in standard deviation is in B, because more of the data is close to the middle. Looks like the mean is close to 2, maybe slightly higher than that. But most of the data is they're close to the mean, and then trails off on both sides. So that's going to be a small variance. Distribution C has the largest variance. It's more spread out from the mean, and A is somewhat in between those two. Okay. So hopefully that gives you some idea a little bit about computing mean, standard deviation, variance, and even skewness, and also a little way of interpreting that graphically for discrete probability distributions.